Welcome to Unit 6, which is Trigonometry for Pre-Calculus of Math 11. Today we're taking a look at trigonometric ratios in all the quadrants, not just quadrant 1. So when we draw an angle in standard position, we can determine the coordinates of the terminal point. That's a point which is on the terminal arm, either by defining it in terms of primary trigonometric ratios, that's like sine, cos, tan, or by thinking of drawing a triangle with respect to the x-axis. So we've kind of seen this in quadrant 1. In the previous section we defined these ratios in quadrant 1, but the same concept extends to the other quadrants as well. So I'm just going to label the sides as x and y, and I'm actually going to put down negative x, negative y for now, just to show you that because it's left in quadrant 2, that would indicate a negative direction. We have an understanding that left is negative and up is positive. So let's take a look at our ratios here. If I want sine of theta, sine is opposite, which is y, over hypotenuse, which is r. Oh, that's positive, two positive values. If we go with cos, cos is adjacent over hypotenuse, so a negative over a positive is negative. And tan is opposite over adjacent, so a positive over a negative is also negative. So we see that in quadrant 2, only sine is positive. Sine of an angle in quadrant 2 is positive. We can extend this to look at quadrant 3, quadrant 4 as well. That would be negative x because it's left. That's down, so that's negative y. In quadrant 4, right is positive, down is negative. So maybe what you should do is hit pause here, see if you can write out those ratios for each of the triangles. Sine theta, cos theta, figure out what's positive and what's negative. Hit pause now. So if we take a look at sine theta, that's negative y over r. That's negative. Cos theta, negative x over r. Oh, look, that's negative as well. Tan theta is opposite, so negative y over negative x. So two negatives dividing, though, gives us a positive. So tan's positive in that quadrant. And let's just tear through quadrant 4. Negative y over r is neg. Cos theta is x over r. That's positive. And tan theta is opposite, which is negative y over adjacent, which is x. And that's negative. So cosine's positive there. We can generalize this by saying, you know what, which trigonometric ratios are positive in which quadrants, just by looking at the positives and negatives from above. So we've seen that in quadrant 1, all ratios are positive. Let's maybe just write down which ones are positive. Here's sine, quadrant 2, sine's positive. Quadrant 3, tangent is positive. And quadrant 4, cosine's positive. So let's just shorten that a bit. When I say that all ratios are positive, let's call that an A in there. All of them stands for all. S stands for sine, T stands for tangent, and C stands for cosine. So this is like a little rule, a little cast rule we call it. We use the term cast, C-A-S-T, to help us remember which trig ratios are positive in which quadrants. So where is sine positive? Sine would be positive in the A quadrant and the S quadrant. Tangent would be positive in the T quadrant and the A quadrant. So it's just this cast rule, a little quick way to remember where are trig ratios positive or negative. Now, we can do this, and it's not terribly hard, by just thinking in terms of the points. So here, the point negative 3, 2 is on the terminal arm of an angle theta. Draw it in standard position. Okay, well, let's draw that in standard position first. Negative 3, 2 is up in quadrant 2, because that's negative 3, and that's a vertical value of 2. And we don't know the radius, and we'll call that theta. Draw theta in standard position, determine the exact value of the primary trigonometric ratios, and then determine the value of theta. Well, let's figure out our r here first. r squared is 2 squared plus negative 3 all squared. Remember, a negative squared should give you a positive. And we get r squared equals 13, so r is plus or minus 13. Now, radius is always going to be positive here. If we want to take a look at the sine ratio, cos ratio, sine theta is opposite over hypotenuse. There's a nice exact value, 2 over root 13. We can do that for cosine as well, negative 3 over the hypotenuse of root 13. And tan theta, opposite over adjacent, so 2/3 negative style. Let's take a look at computing the angle theta. So what I want to do is I want to pretty well always use the positive one, because that will give us a nice reference angle. So here we have sine theta equals 2 over root 13. Theta sub r then is the second function, or arc sine of that, of 2 divided by 13. And we get a reference angle of 33.7 degrees. And because it's in quadrant 2, our answer is actually 180 degrees minus 33.7 degrees. Because again, remember that theta sub r is just that reference angle. And here, rounding, we get 146 degrees as a final answer. So let's determine the exact value for all trigonometric ratios for the standard position angle of 120 degrees. So 120 degrees. Is 120 degrees bigger than 90 degrees, which is straight up? Yep. Bigger than 180? No. So we'll just draw a line in quadrant 2 in this case. That's 120 degrees. Take a look at our steps. Draw the angle in standard position. Great, we did that. Determine the reference angle. So the reference angle is my little blue angle here. And the values I'm using are 180 degrees and 120 degrees. So that's 60 degrees. Draw the appropriate exact value triangle, making sure to label sides as either positive or negative. So here's the thing. Because this is actually a 60-degree angle, that is a 30, 60, 90 triangle. And we can label the sides. I know it's a 2 for the hypotenuse. The opposite of 60 is root 3. And the adjacent of 60 is 1. And because that's left, I'm going to make it negative. So pretty straightforward. Now we can just pick off the ratios. Sine of that angle, which in this case was 120 degrees, is opposite over hypotenuse. So it's positive, great. Cos theta is negative 1 over 2. And tan theta is opposite over adjacent. So root 3 over negative 1, or if you want to call it negative root 3, that's fine. So there we go. Two kind of question types, either exact value or point. And finally, we can talk about the above definitions for each of the 3 trigonometric ratios to determine what the values are for angles that are on the cardinal direction. So it doesn't really make too much sense when we talk about, what's sine of 0 degrees. 0 is straight right. But we know that cos theta is x over r, whatever the x coordinate is. Sine theta is y over r, and tan theta is y over x. So what I did here is I took a look at cos theta as x over r. The radius is always 1. So I just filled in the table. Let me do it for the sine for you. Sine theta is y over r. So here the y coordinate is 0. Radius is always 1. So 0 divided by 1, that's 0. Y coordinate is 1 over 1. That's 1. Oh, that's great. 0 over 1 is 0. Negative 1 over 1 is negative 1. And 0 over 1 is 0. So really what I'm doing is I'm taking a look at the point on the terminal arm. That would be these values here. And I'm just picking off what the coordinates are. So tan is a little bit funny. Tan, let's go opposite over adjacent, y over x. So 0 over 1, well, that's easy, that's 0. This would be 1 divided by 0, which does not exist. We don't know how to divide 1 by 0. Weird things happen. 0 over negative 1, that's 0. negative 1 over 0, that does not exist, and 360 should be back to the very same as 0 degrees. So there we go. You might want to remember the cardinal directions, thinking about, cosine is 1 at 0 degrees, 0 at 90 degrees, etc. This ends the notes for trigonometric ratios in all the quadrants.